Hello. In this video we're going to talk about the conservation of energy and the work-energy theorem. This is really important. It can show us in principle how we really work with energy. Now I'm going to do this a little differently from a pedagogical perspective. First I want to show you the formula, and then later on in the second video, for anyone who's interested, and I really do suggest it, I'll show you where that formula comes from. It's not a very difficult development, and I think it can really be a great enrichment, but it will be in the second video. So keeping that in mind, it's as though we're starting from the end, and then we're going to move back towards the explanation. But putting the pedagogy aside for a second, let's get started. So the first formula I want to introduce to you is the formula for kinetic energy. Kinetic energy is symbolized by E sub k, and it's a set formula which equals 1/2 mv squared. For now we're going to treat this as a definition. For those who are interested later on in the second video, I will explain where this formula comes from. But if you look at it, it's important to understand it as is also. It's 1/2 the mass times the velocity squared. Now if we're squaring the velocity, we're squaring a vector, and if we square a vector we get a scalar value. We get a value with no direction, only magnitude. So kinetic energy, as well as all other types of energy, are always in terms of scalars. The second kind of energy we're going to talk about is potential energy. We talked about it in previous lectures in the sense that it is equivalent to the work that a certain force will be doing. It can be symbolized with U or with EP sometimes as well. And depending on the force at work, it can be equal to different set functions or set equations. Two of the most common examples are the gravitational potential energy, which is mgh, and the elastic potential energy, which equals 1/2 of k delta x squared. In Physics 1, we'll almost exclusively use the potential energy of gravity and the potential elastic energy in our problems, but there exist many other types of potential energy as well. The last energy I want to talk about is total energy or general energy. It's basically the sum of all of these energies. It's symbolized with E. It can also be called the mechanical energy, and it equals EK, the kinetic energy, plus U, the potential energy. Or more accurately, EK plus all the various types of U that we might have in a given problem. In one particular problem, we will probably encounter gravitational potential energy. There will probably be an elastic potential energy in certain problems as well. And there may be multiple other kinds of potential energy associated with the same problem. So our total energy equals our kinetic energy plus all the different types of potential energy in the problem. So when we're talking about our total energy, which we can also call our total mechanic energy, we always have a constant kinetic energy, which is always 1/2 mv squared, and we have multiple formulas depending on the different potential energies we're using. So our total energy, or again our total mechanic energy or mechanic energy, is going to be changing depending on what potential energies we're dealing with. Now I want to give a deeper explanation in the next video for those who are interested, and the larger question still remains: how do we use these terms? Or maybe more accurately, how do we use these terms to solve problems in physics?